Okay, so we have defined the volume of this frustum, we have derived the concept of volume. After that, let us derive the concept of curved surface area of frustum. Now, what should be the curved surface area of frustum? I can again see that this frustum is formed by cutting this cone into two parts. It means if this cone is cut from this line, then the above curved surface area, means the curved surface area of this smaller cone will be removed. So simply what I can see is the curved surface area of frustum can be written as curved surface area of larger cone minus curved surface area of smaller cone. Okay, this is a simple concept that we can understand, that the curved surface area of frustum can be defined as curved surface area of the bigger cone, and when subtracted from this curved surface area of bigger cone, the curved surface area of smaller cone. I removed this much portion, so I subtracted the curved surface area of this part, and you will get finally the CSA of the remaining portion, that is a frustum. Now, as you know that in case of curved surface area for a cone, we have the curved surface area of cone defined as pi r L, where L represents the slant height. So in this case also we need to introduce one more terminology, that is slant height. Let us say, if I talk about the slant height of this bigger cone, then let us say that the slant height of this larger cone is L1. Let us say L1 represents the slant height of this larger cone, and in similar manner, if I want to mark the slant height of smaller cone, I can mark this slant height as L2. Okay, this height is L2, this AD distance is L2, and this AB distance, or this A to this base, this point is, let us say E, this distance is L1. So what is L1? L1 is slant height of, L1 is what? It is the slant height of larger cone. Similarly, L2 is the slant height of smaller cone. Okay, L1 is the slant height of larger cone, L2 is the slant height of smaller cone, and in similar manner we have defined the slant height of this frustum also. So let us define the slant height of frustum as L. Okay, let us say L represents the slant height of frustum. Okay, L represents the slant height of frustum. Now, how the frustum is defined, how the slant height of the frustum is defined, let us first understand this concept. This is the frustum that we have. This is the frustum, and in this frustum, this is the height of the frustum, H. Okay, this is the distance between the two bases, and this is the radius of the above surface, that is the base 2, and this is the radius of the smaller surface, base 1, R1, and slant height of this frustum is this length, that is the distance between the two corners of the two bases. Okay, this is one corner of the base, this is another corner of the second base. So distance between them is the slant height. Now, how to relate slant height and these three parameters? Let us see that if I draw a line from this point, from this corner to this base, like this is a perpendicular line. This height is also perpendicular to the base and this line is also perpendicular to the base. What I can see is this is a rectangle. This is a rectangle. In this rectangle, this line and this line are equal. Okay, these two lines are equal because I can see this forms a rectangle. It is simply because this angle is 90, this angle is 90 and this angle is 90. That's why the fourth angle has to be 90. So if this is h, then this line will also represents h. Why? Because it's a rectangle. Similarly, if this is R2, then this length is also R2, this is R2, this length is also R2. So what about this remaining length? What about this remaining length? This remaining length will be simply R1 minus R2. Okay, this remaining length will be simply R1 minus R2. Now try to observe a triangle, try to observe a right angle triangle. This point was, let us say, we named this point as D. This point was D, this point was B and this point was O, and let us assume that this point is P. So observe the triangle DPB. In the triangle DPB, it's a right angle triangle where this DP represents the slant height or the hypotenuse of this triangle. This PB represents the base and this DP represents the height. So I can apply Pythagoras theorem and I will get that DB square is equals to DP square plus PB square. In place of DB square I can write L square is equals to, in place of DP square I can write H square plus in place of PB square I can write R1 minus R2 square. Simple. And from this I can get L is equals to square root of H square plus R1 minus R2 whole square, and this represents the slant height of this frustum in terms of H, R1 and R2, that is the height of the frustum and the radius of base. So this is, we have the length of slant height. Now, but our task was to define the curved surface area of frustum, and we define it using the two curved surface area of the two different cones. So here also our task will be what? Our task will be to define L1 and L2. Our task will be to define L1 and L2. L1 is slant height of larger cone, L2 is slant height of smaller cone. So our task will be to define L1 and L2 in terms of L, R1 and R2. Okay, this will be our task. Simple, that we need to define L1 and L2 in terms of L, R1 and R2. These are the three values that we need to use. So first to note this, take a quick 30 seconds break and we will start solving from here. Now we will define this L1 and L2 in terms of L, R1 and R2. Okay, so first note this. Okay, so we have the slant height of frustum as square root of H square plus R1 minus R2 square. Now let us define the slant heights of the two cones. What I can see is, as we have proved previously, that triangle ACD is similar to triangle AOB. We have seen previously that these two triangles are similar to each other. That's why the ratio of their sides has to be equal. So similarly, in the previous case what I took is, I took this AC and this AO, then this CD and this OB. But now I will use AB, this AD and this AB and CD and OB. Okay, here since these two triangles are similar, we have proved this previously, I can write AB AD upon CD is equals to, or let us say AD upon AB is equals to CD upon OB. I can write the ratio of corresponding sides as equal. So AD upon AB is equals to CD upon OB. Now what is AD? In place of AD I can write L2, in place of AB I can write L1. Okay, this AB is L1. I have marked AB here, this is L1, so this AB is also L1. So in place of AD I can write L2 upon this is L1, which is equals to CD. CD was R2 divided by OB is R1. This is the condition that we have. Okay, L2 upon L1 is equals to R2 upon R1. Now observe very carefully. What I can see is this complete length, let us mark L1 here also, L1. Okay, this complete length is L1, and if I subtract from this L1, this L2 is subtracted from this L1, I will get this L. Okay, so this complete length is L1. If I subtract from this L1 this L2, then I will get L. So I can write L2, or L is basically equals to L1 minus L2. Okay, if I subtract this L2 from this L1, I will get L. So this is L is equals to L1 minus L2, and from this I can get the value of L2 as L1 minus L. This is simply the value of L, simply the value of L2. This L2 is shifted to RHS, L is shifted to LHS, and you will get L2 is L1 minus L. Now we will substitute this L2 value L1 minus L in this equation. So what I will get is, in place of L2 I write L1 minus L upon L1 is equals to R2 upon R1. So if I simplify that value, L1 upon L1 minus L upon L1 is equals to R2 upon R1. So from this what I will get, this L1 and L1 will get cancelled, so 1, and when you solve this it will become R1 minus R2 upon R1 is equals to L upon L1. Okay, it's simply when you solve these values you will get this equation, and from this I can see that L1 is equals to L times R1 upon R1 minus R2. This is the value of L1 that I have. Now I have the value of L1. Similarly, if I want to calculate the value of L2, what is L2? It is L1 minus L. So it implies L2 is equals to L1 is L R1 upon R1 minus R2 minus L. Okay, L R1 upon R1 minus R2 minus L in this formula. And when you solve this value, that is shift this R1 minus R2 to this numerator and solve this value, and finally you will get that the value of L2 is L R2 divided by R1 minus R2. This is a relation that we have. Okay, so we have the values of slant heights in terms of slant height of frustum and the radius of frustum. Okay, so now we use this L1 and L2 to define the value of curved surface area of frustum. So I can write CSA of frustum is equals to CSA of larger cone minus CSA of smaller cone. Now CSA of larger cone is, it is defined as pi R1 L1, okay, minus CSA of smaller cone is defined as pi R2 L2. So in this R1 and R2 also represents the radii of frustum. That's why I will not change these values, but in place of L1 I have this relation, and in place of L2 I have this relation. So let us substitute these two relations. pi r1 to the bracket L r1 upon r1 minus r2 minus pi r2 times L r2 upon r1 minus r2. So this will become pi L r1 square upon r1 minus r2 minus pi L r2 square upon r1 minus r2. Okay, what I did is I multiplied this r1 in this bracket and this r2 in this bracket, so I will get this. Now further, when you solve this value, you will get, if I take pi and L as common from both the values in bracket, it will be left with r1 square minus r2 square upon r1 minus r2. Okay. Now here I can use the identity that a square minus b square is equals to a plus b into a minus b. This is the relation that I can use. So in place of a and b, I have r1 and r2, and I will write it as pi times L to the bracket r1 minus r2 into r1 plus r2 and upon r1 minus r2 as it is. So when you subtract this r1 and cancel this r1 minus r2 from the numerator and denominator, finally you will be left with pi times L r1 plus r2, and this pi L r1 plus r2 represents the surface area, the curved surface area of frustum. Okay, this value represents CSA of frustum. Okay, so in this manner I need to derive the CSA of frustum, but mind it, we have just derived the CSA of frustum. Our next task will be to define the TSA of frustum. But in that case, we have two kinds of frustum, either is a hollow frustum or a solid. Hollow frustum means the frustum which is made from a hollow right circular cone, and the solid frustum means the frustum which is made up of a solid right circular cone. We will define both the terminologies and define the TSA, that is the total surface area of the two frustums after this. Okay, so first to note this, and then after that we will continue.